Hi, this is Leetcode question, maximum running time of n computers. In this example, the answer is 4. Now, the brute force solution for this question is by creating two priority queues running that holds the currently being used batteries and not running the batteries that are not being used. So, have running holds the batteries that are being used, and this is min priority queue, and we have not running that holds the batteries that are not being used, and this is max priority queue. Initially, we push the maximum in batteries to the running queue because we want to use the batteries that has the maximum value. So we sort in reverse order, and we push the first in batteries, or the maximum 2 batteries to the running queue, and the last one we put it in the not running. Now at every minute we subtract, so at first minute we subtract 1 from both batteries that are running, so 2, and we add 1 to the answer, so answer plus 1, and we push the value, or we subtract 1 from the value in the running batteries. Now the top of the min priority Q2 is less than the max, and because we want to use the batteries that has large value, we swap these two batteries. So here we'll put 3, 2, and this 2 we push it to the not running. Now at time 2 we subtract 1, so 3 minus 1 is 2, 2 minus 1 is 1, and we add 1 to the answer. Now this is 2, the maximum, and this is 1, the minimum, so we swap. This becomes 2, 2, and this is 1. At time 3 we subtract 1, so 1, 1. We add 1 to the answer. Now this is 1, this is 1. We don't need to do anything. At time 4 we subtract 1 from both running batteries, so we have 1 minus 1 is 0, 1 minus 1 is 0, but we don't push the 0 into the queue. We increase the answer by 1, we have 4, and we bring this, the not used 1, to the running queue, but the size of the running queue is 1, which is less than the size of the number of computer. So we break the loop here and we return the answer. Answer is 4. Notice here we almost took advantage of every minute in the batteries. So here we have 3 plus 3 plus 3 divided by the number of computer is equal 4. There is 1, it's not used. Another example is 5, 2, here 5, 2, 2, 2, 2, 2, and we have 3 computers, so we have running and not running. And remember, this is max priority queue and this is min, and we push the maximum 3 batteries to the running, 5, 2, 2, and the last, or the remaining batteries, we put them in the not running. So here we have 2, 2, 2. At time 1, or the first minute, we subtract 1 from the running, and we increase the answer by 1. Now the minimum of this queue, these values are less than the maximum of these values, so we swap. This value becomes 4, 2, 2, and we bring the 1, 1 to be in the not running queue. So here we have 1, 1, and 2. Now at time 2 we subtract 1, 3, 1, 1, and we add 1 to the answer. Now this one is less than the 2, the min is less than the max, so we swap. So this becomes 3, 1, 2, and this one 1, 1, and 1. Now at time 3 we subtract 1, so this is 2, 0, 2. We don't push 0 into the queue, and we bring 1 battery from the not running to be in the running queue. We add 1 to the answer, so we have 1 and 1 here, and 2, 1, 2 here. Time 4 we subtract 1, so 1 minus 1 is 0, 2 minus 1 is 1. Increase the answer, and we bring 1 from notice here we subtracted 1, 2 minus 1 is 1 here, and so then 2 minus 1 is 1, 1 minus 1 is 0, 1 minus 1 is 0, so we bring these two to cover the zeros values. Now this is empty, and here we have 3 ones. Time 5, 0, but we don't push 0, 0, 0, and the answer is 5, which is the last answer. So notice here the pattern is this max value here 5 is reducing, and the other 2 batteries with these 3 are compensating while this is going down, and these batteries, every minute in these battery are being used, so it's kind of balancing the max values with the min value, and this tells us that every minute in these batteries will be used, and this will lead us to the proper solution, because this solution will give TLE, since we cannot just go with time because the values are large. So the proper solution, because we know that we are using all the values in on the batteries, what we will do is doing binary search among whatever give us the best answer, and if we have this function check that tell us if it's possible to meet some or to have the target as an answer, so check target. If return true, we try with the higher value. If it return false, we try with lower value. Now how this function works, the same. From this example we know we are taking advantage of every minute of the batteries, and the other fact is if the battery itself, so assume we have 6, 2, 2, 2 the last example, and we want to check if the target equal 5 can be achieved. So the other fact is this battery 6, it's impossible to run more than 5 minutes because we need the whole thing to run for 5 minutes. So if we clip this value to 5 and then we check if it's possible to give this target, and because we said we take advantage of every value in the batteries, we just do the summation. So here we have 5 plus 2 plus 2 plus 2 plus 2, this is 2 plus 2, this equal 15. Now 15 divided by the number of computer equal 5, and because this value 5 is greater than or equal to the target, that means this target is can be achieved, and in this case we search for greater or value greater than the 5. So simply we have two steps. We clip all the values greater than the target to the target itself. So if we have 7 here and we are looking for 5, also we set it to 5 because this battery, it's impossible to use all its value more than 5 minutes. So after clipping, we just do this condition, accumulating the value, and check this condition if sum divided by n is greater than or equal to target. And initially here we set the left value to 1 and R to the max value, because here we have 10 to the power 5, the length of the array, multiplied by each value is 10 to the power 9. You can modify this value by calculating the average, but this should work, and the time complexity for this is big O of log of this value multiplied by the complexity of this, which is n.